So in the last video I told you I'd explain why ionic compounds form sometimes and why covalent compounds form at other times. So we're going to look at this example. We've got A and B. They've each got a red electron. Let's say that's their valence electron. Now, if an ionic bond were to occur, B might steal the electrons and become negative, and that leaves A positive because it lost an electron, or they might decide to share their electrons. And so now A and B each think that they have an extra electron that they didn't before. A thinks that it also has B, and B thinks that it also has A's electron. So how do we know which type of bond will form? A and B, how do I know that it's going to form an ionic bond? Or how do I know that it's going to form a covalent bond? So that's the question that we are going to answer in this video. And then we are going to learn how to draw the different types of bonds and learn a little bit more about their properties. So the first question that I'm going to answer is, how do I know it'll form ionic or covalent? And the answer to that is, what is the difference in electronegativity? So you have this scale on your yellow sheet. If you find the difference in electronegativity between two elements, it'll fall somewhere on this spectrum. And depending which gap it falls into, we will decide whether the pair will form an ionic compound or a covalent compound. And you can see that we have polar covalent and non-polar covalent as options. We'll explain those more as we go here. We will label them I, PC, and NPC. So if you want to write that on your yellow sheet, you can write I, PC, and NPC on that yellow sheet. And one quick thing to note, if you're observant and asking questions here, you might say, well, what if my difference lands right on 1.7? Which way does that go? Does it go this way or this way? And the answer is they always fall to the left. So if you get 1.7, that's ionic. If you get 0.3, that is polar covalent. So that's how we'll treat those. Now, where do you find the electronegativity? So what you're going to do is you're going to go to your yellow sheet, and you'll notice right here you have the little scale that I gave you. So you can write I, PC, and NPC under there. So if you missed that, I, PC, and NPC. So I'll let you write those down. But the electronegativities, you'll see there's a chart here. This isn't it's a little bit blurry, but it's good enough to read here. This has a list of all the elements. Obviously, you got the periodic table, and it tells you their electronegativities. You will notice, however, though, that the noble gases are gone on this periodic table because we said they have zero electronegativity. Also know that fluorine is the highest, most electronegative element. It has an electronegativity of 4.0. And then you can see francium down here has 0.7. Cesium also is very low. But you can see that it does, if you check, it tends to get higher as you go up, and the electronegativities also tend to increase as you go this way. Now, it's not a perfect trend. You can see like here, it goes 1.8, 1.9, 1.6. But for the most part, it increases going to the right. Okay, so the types of bonds. The first one is a non-polar covalent bond. So it fits into this category. So non-polar covalent bonds, it is a covalent bond, and the electronegativity difference is very, very small. So it's anywhere from 0 to 0.29. If the difference between the two elements is really, really low, those two elements will bond and form a non-polar covalent bond. Now, what does that mean? That means when they bond, they will share their electrons very equally. It's a very equal sharing opportunity. Both atoms spend about equal time with the electrons, and that's that. And we'll talk about the other type here in a second. But an example is H2. We'll get rid of that for now. Here's how I would draw this. The first thing I'd do is I'd say, okay, I've got H and H. The difference between them is obviously going to be 0. They're both 2.1. If I remember right off the top of my head. I don't actually have a yellow sheet, so correct me if I'm wrong. All I know is the difference is going to be 0. So to draw this bond, I would draw H dash H. This bond here represents the shared pair that they're sharing, and they're going to share the electrons equally. So each atom will have the electrons for half the time. A polar covalent bond occurs when you have differences in this range, 0.3 to 1.69. Now this is also a covalent bond, but the atoms will not share the electrons equally. So there is a little bit bigger of a difference here than there was here. So one of the atoms is going to be a little bit more electronegative, not enough to be able to steal it from the other atom, but enough to be able to hog the electron and to hold on to it a little bit more often than the other one. So it's not sharing equally. So an example is HCl. If we look up their electronegativities, we've got H and Cl. You find the difference. Let's just go with the absolute value. It's 0.9. Well, 0.9 falls into this range. So what I do is I draw both atoms, HCl. Because it is a covalent bond, I draw a dash. That dash represents a covalent bond. But in this case, I have to, oh, excuse me, suddenly got the hiccups. I also have to draw symbols to illustrate which atom is hogging the electrons. In this case, chlorine is more electronegative, not enough to steal the electrons from hydrogen, but enough to be able to pull them away and leave hydrogen a little less, with a little bit less than its fair share of the electrons. So what we do is we draw an arrow saying the electrons are going to get pulled more towards chlorine. That will leave hydrogen with a slightly positive charge. Not a full positive, but slightly positive. So you put like a little plus tail. So it looks like there's kind of a plus at the end of the arrow here. There is another way to write this. You write H-Cl, and then you write a little, it's like an S with the closed on the end, or like an unfinished 8. And we'd say chlorine is going to be partially negative, and hydrogen is partially positive. This symbol means partial. So one of the atoms will have the electrons for a greater amount of time, and it will always be the one that's more electronegative, because that one wants them more. So in this case, chlorine will be hogging it. The electrons spend more time with chlorine. That will make chlorine a little bit extra negative than it would be if it were neutral. So that little symbol there, I'll erase, means partial, if you didn't catch that. An ionic bond. This is when the electrons transfer. So you'll have a big difference. And this slide is not in your note outline. So you have a big difference. That means that one atom is really strong and one atom is really weak, which allows the strong atom to fully rip the electron away from the other one. So the atom that loses the electron will be positive. The atom that gains the electron will be negative. It'll always be the more electronegative one that steals from the less electronegative one. So an example is NaCl. If we look up their electronegativities on the yellow sheet, we'll find them here, 0.9 and 3.0. The difference between these is 2.1, which falls into this category. And that makes it ionic. So first we'd identify it as obviously forming an ionic bond. Now the next thing is I draw the symbols. And the notice I did not put a dash between them. That's because this is an ionic bond, not a covalent bond. If you remember from the last video, ionic bonds do not have individual bonds holding them together. So we do not draw the dash linking them together. But now I have to draw the positive and the negative symbol. The more electronegative, which is chlorine, will get a negative symbol, and the less electronegative will get a positive symbol. You do not have to put the magnitude of the charge. Is it +1, +2, +3? Just put plus and minus. That's all I need. So remember Ionic, one atom will completely steal the electron. So now we have full charges, not partial charges. So a little review here. Ionic bonds, the electrons transfer. There is no individual bond, and you draw the bond like this over here. No dash, full charges. Polar covalent, they share, but it is not equal. There is an individual bond. That's why we draw this dash. And then you have to indicate the partial charges. So I always like to think PC, polar covalent, also stands for partial charge. So PC, remember PC, partial charge. And then NPC, non-polar covalent, they share equally. So it's a very neutral, no partial charges anywhere. And there still is an individual bond because it is covalent. So you do not draw charges, you just draw a dash and you're done. So I think NPC stands for no partial charges. So let's practice here. This is what you're going to be asked to do on your types of bond worksheet. The first thing you have to do is look up the electronegativities. Now, I don't have a yellow sheet, so I pre-set them in here. So we've got 1 and 3. The difference between these two is 2.0. 2.0 would mean that this is an ionic compound. So I'd label it as I for ionic. Now to draw it, I draw the elements LiCl. I do not put a dash between them, but I do have to put charges. The negative always goes with the more electronegative. So think negative, more electronegative. The negative always goes with the more electronegative. And then the positive goes with the less electronegative. So I'm done. No dash. I got my charges, my plus and minus, I'm good. Now for the next one, you look up the electronegativities. The difference is 0.4. That lands in the PC category. So we know that's going to have partial charges and it's covalent. So it's covalent, so that means I draw a dash. And then PC, partial charge. The partial negative goes on the more electronegative, which is the carbon. So I'd go like this, partially negative, and this one would be partially positive. I would also accept this as an answer. You know that the carbon is more electronegative, so it's drawing the electrons this way. And then the hydrogen will be left slightly positive. P and O, 2.1 and 3.5. If I'm doing my math right, that adds up to 1.4. The difference there is 1.4. This one's the more electronegative. 1.4 lands in the PC category. So I write P-O because it's covalent. Make sure you put that dash. And then I am going to draw the arrow towards the oxygen with the little plus over the phosphorus. Two more. We've got 2.5 and 4.0. I do my math there. That adds up to 1.5. That is also polar covalent. So I draw my dash between them if it's covalent. If it's either PC or NPC, if it's got a C for covalent, you better have a dash. Okay, partial charge goes on the more electronegative, which is fluorine. The partial negative anyways. The more electronegative gets the negative. That means that this one will be partial positive. And again, these are two ways of doing partial charges, so either of these would be acceptable. So if you want to do it with the arrow, that's fine. Just make sure your arrow is going that way with the plus over here. The last one, SE and I, the difference is 0.1, so that is NPC. So that stands for no partial charge. So I write SE-I, and I am done at that point. SE-I, no partial charges. So you draw the dash and you are done. So use this. This is how you do your worksheet. You circle the more electronegative difference type of bond, draw the bond, and that's where we will end this video.